This video will talk about the last practice exercise for our unit number 2, which is concerned on the absolute value equations. And probably this would be the last type of equation that we're going to talk to for this grade level, but doesn't mean that we're not going to talk about equations anymore. We are still going to talk about equations as we go through the rest of the topics for Math 7. But this is our last special type of equations, the last video for our special type of equations, the absolute value equation. So in the previous video, we were able to learn that in solving the absolute value equations, we're going to need to come up with two cases. The first case, I'm still going to write it here. So is for example, if we have the expression absolute value of x is equal to 3, the case 1 is taking the value of the expression here, x, equating it to the positive value of your right hand side. And the second case is x, same expression, is equal to the negative value side. And then we uh, took pride in determining the checking first before the solution set, because what is asked here is the solution set. We need to check it first, and we need to train ourselves not to be relaxed and not to jump any conclusions. And I'm going to show you why probably in one of the items here in this practice exercise. To start with, let's talk about item number 1. So again, our first case here is taking the whole expression. That's our case 1. 3x plus 12, equating them to the positive value, but since 0 is a non-positive, non-negative, we still have 0. The second case is again taking the same expression and placing and equating rather it to the negative of the value, which is 0. Well, some of you might argue, sir, there's no such thing as negative 0. Okay, I also believe, and also with that the idea, but just for the illustration of the two cases, let me just have that one. Nevertheless, I'm going to give you a short uh, summary later on in connection with the two cases, with the concept that there is no such thing as negative 0. But as of the moment, stay as it is. Let's try to solve both cases by again letting this as stand in the meantime. So we have here, we are going to subtract both sides first by 12. That's 12. Sorry, let me rewrite it. That's 12. This will become 3x. 3x is equal to negative 12. Divide both sides by 3. So our value for x is negative 4 for case 1. As for case 2, we are still going to subtract both sides by 12. By the way, this is 12. This was 12. Sorry for that. Pardon. Going to subtract both sides by 12 still. And you will come up with 3x. That's 0. The other side, again, just by letting the sign here for 0 as negative, even if, again, there's no such thing as negative 0, when you combine that, it will still become negative 12, right? So it will still become negative 12. But as you can see, when we divide both sides by 3, even in just this level only alone, you might come up with the same value for our variable x, which is negative 4. Okay? This means this is again the support of not anymore placing this, because this will actually be still 0. The point here is that for these two cases, we still have the same result, because our right hand side value here is just 0, which will actually non-positive and non-negative. In short, they will just be the same. Okay, so in your future computation, if this is actually equal to 0, you may just simply give us one of the two cases. But in the meantime, I'm showing you the two cases to show that if the right hand side is 0, the result for both cases are just the same. And since the result for both sides are just the same, we will just need one checking. Do not be stressed in showing two checking, because they're just the same. So let me use again the original equation. So you have 3 times negative 4 plus 12. The absolute value of it is it 0? Let's try to find out. This absolute value, let me, yeah, absolute value. So 3 times 4 is negative 4 rather is negative 12 plus 12. So question mark 0. Negative 12 plus 12 is 0. And the absolute value of 0, or in short, the distance of 0 from 0 is 0 itself. The other side is also 0. They are now the same. Okay. So since we have the same values and both of them will have only one checking, this means that both of these values are already acceptable. And then our solution set should contain the solutions based on the verification of the checking. However, this is now the one of the important analysis that you need to make when we talk about absolute value equations. In the previous practice exercises, in practice exercise A rather, in items 1 to 4, we will have two possible solutions. And by checking, we have determined that all of those items have two solutions. In writing them in a roster form, you may interchange the two solutions. However, for this item number 1, since the right hand side is 0 and you will have the same expression for both cases, you will have the same values for x, the same checking, you cannot place negative 4 and negative 4 here. If you can still remember, when you write sets in the first grading, it's okay to for elements to be interchanged, but strictly no duplication. Since negative 4 is already here, don't need to write negative 4 here. Okay, so we only have a unit set containing negative 4, and the analysis will come in. In absolute value equations, it's possible to get two solutions or one solution, just like in number 1. You only have one solution here because again, there should be no duplication. So this is an important analysis you need to make when coming up with absolute value notation. So it's not all the time that you will get two solutions. There will be times wherein that you could also get only one solution. Let's proceed to number 2. Number 2 allows us for case 1 to again take this x minus 3 and take the positive of this, which is let's just say positive 1. Nevertheless, two cases will just may just be interchanged in a solution set. In the case 2, we'll take x minus 3 and take the negative 1. Okay. Okay. You might argue, so I will place your negative, I'll place your positive. It's okay. Because again, if both of them are solutions, you may interchange them in the solution set. So let's solve both of them. Add 3. Sorry, that's 3. Add 3. Still here. Add 3. Add 3. That becomes 0. We have x is equal to 1 plus 3, which is 4. Okay. And then the other side, that's 0. This is negative 1 plus c is positive 2. So these are the two possible values for x. Again, do not say, I'm okay with that, sir. I am 100% sure that those two are solutions. I do not need any more checking. My solution set should contain 4 and 2. Okay? So this is also the example I am talking about in the previous video in practice exercise A that you need to watch out for. And you need to always verify using checking. Because yes, there are two possible solutions here, 4 and 2. And there might be a chance wherein your solution set should contain 4 and 2 or 2 and 4 interchange. But let's try to check first if both of them are really solutions. So per checking, we need to use not this one, but it should use the original given expression. That's what the substitute there. So you have 4 minus 3, is it equal to negative 1? 4, negative 1, because that's the value here. So 4 minus 3 is positive 1, question mark, negative. Absolute value of 1 is positive 1. This side is negative 1 based on the given. As you can see, they are not equal. This would mean 4 is not a solution. And writing it in a solution set will invalidate this one, and that's a very big mistake. Okay? This is why checking is very important. For the second value, 2, you have 2 minus 3, question mark here, negative 1. 2 minus 3 is negative 1. Okay. Oh, there will be a chance. Negative 1 here. And you might say, yes, sir, I made a mistake. It's actually just 2 because 4 is not a solution. Let's continue, by the way. When we continue this one, absolute value of negative 1 is not negative 1. Absolute value of negative 1 is a positive 1. And the other side is still negative 1. Again, they are not the same. And similar to the possible value of x, which is 4 earlier, 2 is also not a solution. So what was my point here? When if you will not check your values of x and directly say solution set, you might experience like this, and that will be a very big mistake. So what should our solution set look like right now? Since there are no solutions, our solution set should contain nothing. We know already the name for that. The name for this set is an empty set, or you may use the null set, but let's just use empty set. So there are also times in connection to number 1 in the previous practice exercises, for absolute value equations, the number of possible solutions are 2, or there can be 2 solutions. There can be a 1 solution in just like in example number 1, and there can be none, just like in example number 2. And when do we know? Or when can we identify that there are 2, there are 1, or there are none? Always do the checking. And after all, look at the given examples here. In item number 1, the left right hand side is 0, so you have only one solution. In the practice exercises A, you may want to go back and visit the previous video. The values for the right hand side of the equation are all positive. That's why you have 2 solutions. In here, in number 2, this supports that the solution set here is empty set because of this. Whatever the result for this expression here, it can never be negative under absolute value. Now, that is where the contradiction will come in. That's another hint that you could actually use. Okay, so again, in number 2, yeah, it's empty set. In number 3 and number 4, we have expressions outside absolute value expressions here, notations rather. In number 3, minus 3 is not inside it. Here, plus 5 is not inside it. So you might say, in number 3, sir, this is what I am going to do. For case number 1, I have x plus 1 minus 3 equals positive 2. And my case 2 should be x plus 1 minus 3 equals the negative of 2, because I only applied the cases, sir. We're in take the value and positive for the case 1, take the value and negative for case 2. This is one of the biggest mistakes that you may also do for number 3 and even in number 4. Why? Because when we go back to cases, or just like this one, in the general form, we can only make cases, case 1 and case 2, if the left-hand side is only that absolute value expression. Okay, or only the left-hand side only with the absolute value expression, just like in number 1 and number 2, in this example, and the previous items in the practice exercise A. But in this case, in your left-hand side contains a value outside it. In short, you cannot apply here the cases first or directly. What you need to do this first, again, this is a misconception. I will remove this one. This is a misconception. I will remove this one. What you need to do first here is to make sure that this will be removed here by adding both sides by 3. Why do we need to do that? So that we could remove this, the item outside the absolute value notation. And by removing that, we could now apply the cases. Because this becomes 0, it shall become x plus 1. The other side, negative 2 plus 3, is actually positive 1. This is another form of the example here. And this can be applied already to 2 cases. This is where we could apply the cases now. And the cases shall be case 1, x plus 1 is equal to positive 1, not anymore with this expression. And number 2, we have here x plus 1 is equal to the negative of 1, not anymore 2 because we already added both sides by 3. Again, do not apply directly the cases if we have expressions outside the absolute value notation. So let's try to resolve both of this. So you're going to subtract both sides by 1. So you will have this expression x, that's 0. The other side is also 0. Here, we will subtract both sides by 1. So you will have this expression. This is 0. Negative 1 minus 1 is not 0. Check your integers. That's negative 2. So again, do not jump into the conclusion and saying these are solutions immediately. Always do the checking. But mind you guys, when we are going to check, we are going to use not this one here. Why po? Because there might be problems or there might be errors from moving to this example, this expression to this one. So if there are errors from moving here to there, and you applied or you checked these items in this area here, even if it will satisfy this equation here, but there are mistakes from step 1 to step 3, it will invalidate all and will make your answers incorrect. So when we do checking, we are going to substitute these two values in the given equation, not here, so that we could remove any possibility of a mistake. So when we do that, substitute here 0 plus 1 minus 3 question mark negative 2. Second checking, negative 2 plus 1 minus 3 negative 2 question mark. 0 plus 1 is 1 minus 3 negative 2. No need to remove the 3 here, negative 3 here. No need to remove this one because we would just like to take uh, or find out if both sides will still remain the same or balanced or still equal. So absolute value of 1 is 1 minus 3 question mark negative 2. 1 minus 3 is negative 2. The other side is already a negative 2. That's correct. Therefore, we accept 0 as a solution of the given equation, not just of this form here. And then for checking for number 2, negative 2 plus 1 is negative 1 minus 3 question mark negative 2. The absolute value of negative 1 is positive 1 minus 3 question mark negative 2. 1 minus 3 is negative 2. The other side is already a negative 2. This is already balanced. Therefore, this value, negative 2 for x, is also acceptable as a solution. This is the time that our solution set shall become 0, or a set containing 0 and negative 2, or the other way around. Okay, so again, no need to uh, apply the cases here first. Okay, just simply make sure that one side contains only absolute value notation and nothing else. And when we do checking, check the original. And when we do checking further, no need to remove the item that you have removed here. Just make sure that both sides will be the same. Let's apply that for number 4. Do not do cases here first. We need to subtract both sides by 5. So you have here 2x plus 4 is equal to, that's 0 already, 6. And then this is where your cases will come in. Case 1, 2x plus 4 is equal to positive 6. Case number 2, 2x plus 4 is equal to negative 6. Solve them independently. You need to subtract both sides by 4 here, here as well. So you will have the expressions 2x, that's 0 already. 6 minus 4 is positive 2. Divide both sides by 2. The value for x in case 1 is positive 1. For case 2, you will have 2x, that's already 0. Negative 6 minus 4, check your integers, that's negative 10. Divide both sides by 2. Cancel that out. The value is x is equal to negative of 5. Before a solution set, again and again and again, checking. But we are not going to use this. We are going to use the original expression. So you have there 2 times 1 plus 4. Outside is plus 5. Is it equal to 11? Let's check the first condition or case first. So you'll have here 2 times 1 is 2 plus 4 plus 5 outside, question mark still 11. 2 plus 4 is 6 plus 5, question mark still 11. Absolute value of 6. Don't be too lazy to continue. Just simply continue and continue. 6 plus 5, even if it's too obvious, question mark still. 6 plus 5 is 11. Here is 11. They are now balanced. This means 1 is a solution. Checking for the second case, using the given equation here. So you have 2 times negative 5, this is absolute value, plus 4 plus 5 outside, question mark 11. Again, no need to remove this 5 here, and you might say, I will subtract both sides by 5, sir, same as this. No need to, because that's already checking. So you have, in checking, you simply need to substitute or evaluate the expression. No need to apply the properties of equality. 2 times negative 5 is negative 10 plus 4 plus 5 here, question mark still 11. So you have you have negative 10 plus 4 is negative 6 plus 5 here, question mark 11. Absolute value of negative 6 is positive 6. You have 5 here, question mark, even if it's too obvious, because our goal is to make the both sides equal. 6 plus 5, 11. 11, we have arrived to an expression where they are the same. This means negative 5 is also a solution. So our solution set finally shall contain 1 and negative 5, or the other way around. So these are the processes for extended analysis needed for absolute value equations. The first practice exercise A on the previous video, talks about basic forms. And now we have here, I'm not saying these are the most difficult forms. We still have many difficult forms for absolute value equations, but I believe as of this level, this could suffice your understanding. So again, here, there might be chances wherein you might only get one, or there might be none, or same as number 3 and 4, there might be two solutions. But in number 3 and number 4, do not apply the cases first or directly. You need to uh, manipulate it or derive in such a way, in a form wherein you could apply already the cases. So this what completes unit number 2. So please continue on reviewing, because we will have our first assessment soon. Thank you very much. Goodbye.